Hello everybody, thank you for checking out my video to begin our geometry unit. Doing volume for the first couple of days, and if it's not Halloween when you're watching this, please excuse the little background. I like to use my Halloween slides and lights and stuff. But anyways, a couple of very key statements that'll get you out of some bad situations or difficult situations, let's say. A base and height will always form a right angle. Height is always going to connect the bases, if there's two bases anyways. Bases are always parallel to each other. A round shape is always going to have pi and r in it. And volume loves the number 3 is a statement I like to refer back to quite a few times. So step 1, making sure you understand the formulas that you're dealing with. When you have a prism or a cylinder, these are all based on capital BH. But capital B stands for area of a base. It's not just base, it's area of a base. And this is super important because, like in a cylinder, your base is a circle, which is pi r squared. You're going to substitute that in. So if I kind of lost you already, make sure you understand, first of all, your area formulas, which I covered on my warm-up today. Over here, of course, my base is not a circle. It's a triangle. And remember, bases are always parallel, so I know my triangles are the bases. A triangle's formula for area is 1/2 base times height. I'll plug that in for base. So ultimately, a triangular prism is 1/2 the base times height, and then times the height of the prism, which would be right here. Height connects bases. Then finally, you could use like the front and back as your base, or your left and right, or your top and bottom as your bases, because you got a lot of different parallel sets. Remember, bases are always parallel. You're just going to do, if I use maybe the front and back as my base, you're going to do the length, the width, and the height. Length times width times height, because those rectangles would be length times width, and then you still have that height. Hopefully, if you didn't catch on to that, you'll catch on as I go through some of the actual shapes and use the pieces a little bit more. So like we were just talking about, I'm going to use, this time I think I'm going to use the bottom as my base. Bottom and top as my bases. So again, your volume, capital BH. The base is a rectangle, so just length times width, and then I still have that height. In my rectangle, my length and width is 8 and 10 and 8. My height, remember, height doesn't have to be going up and down. Height is going to connect your two bases. My bases always got to be parallel. So I'm using top and bottom as my bases, and it's 5 that's connecting them, which is going to give you 400. So I'm using a flip book that you can find on Teacher Tools, I believe. It's a flip book that has volume and surface area, but in my class we don't have to do surface area. Capital BH over here. My base is a triangle, so 1/2 the base times the height, but don't be confused. We got two heights. We got a height in the triangle, and we got a height of the prism. So focus. The base and the height always got to form a right angle. So it's the 9 and 12. I almost used 7. I actually had to back up my video. Did that in class as well. 9 and 12 are the sides that make the right angle. Like this and 15 do not make a right angle. So 15 is not part of my base and height. 1/2, 9 times 12. And the height of the prism, remember, height always connects the bases. It's this 7 that's connecting the bases. So whatever you type this in your calculator to get, that's the volume. So volume is also, note, volume answers come out in cubic meters or cubic centimeters, cubic units. So it'd be whatever that comes up to, meters cubed, or over here would have been 400 cubic inches. Basically a whole bunch of 400 little boxes that would fill up this prism. So those are more so middle school level math problems. In my Math 3 class, one of the more advanced versions, and I'll do more advanced types in the second volume video. This is a trapezoidal prism. So every prism is capital BH, but a trapezoid is 1/2 the height times the base plus the base. Then I still got that height from my original formula, the height of the prism. So focusing on just the trapezoids, why am I choosing this, or why am I labeling this as a trapezoidal prism? The bases are trapezoids. Why those? They're parallel to each other. Now you do have a rectangle on top and bottom that are parallel to each other, but they're different rectangles. Remember, height always connects your bases. Make sure you recognize what number in this trapezoid is connecting the bases. It's the 4.3. Base and height, remember, always got to form a right angle. The bases are always going to be parallel. That's these two, the 9 and this, which this would be the same as the 4 in the back. So 9 plus 4. There's a couple numbers we haven't used. How to put the height of the prism. Remember, height connects the bases. That's connecting this front trapezoid to the back trapezoid. Do you know what number is connecting the two? Hopefully you said the 11 is connecting the front and the back. So whatever, 1/2 times 4.3 times 9 plus 4 in parentheses, and then times 11. Of course, it's going to be cubic feet. Nothing really complicated about this cylinder. Capital B times H, the base is a circle, so it's pi r squared H. The radius is 8, not 16. 16 being in the center is representing this whole line. That 16 would split up to 8 and 8. The height, of course, is 21. 21 is making a right angle at the bottom down there. Kilometers seems like a strange unit to use for a cylinder, but anyways. Good steps to follow. Write your formula. Write the original anyway. Substitute the correct base formula. Plug in the numbers that you have from the picture. Use the power statements to get you out of tricky situations, and type your calculation into Desmos or whatever calculator it is you're using. Now, in the next tab, these shapes are a little bit more triangular, you could say. The triangular ones are 1/3 capital BH. You already know about substituting in bases. The bases are circles, so circles are pi r squared, so we will fill that in. Whereas the base over here in a rectangle or square or parallelogram, length times width or base times height, if you want to, for base there. Some of the examples. So again, it's a pyramid. It gets a 1/3. The base is going to be length times width down here. That's the 6 and the 15. They are making a right angle. The height of the pyramid is 4. This is a nice height. It comes down to my base. It makes a right angle. I love it. Whatever the calculation is, cubic centimeters. But 6 is a really good question. When I set up capital BH, 1/3 capital BH, I'm sorry, my base is pretty easy at 16 by 16. What's tricky about this one is 17 is not the actual height. It's called a slant height. It does make a right angle with this edge, but it doesn't make a right angle with the base. If I look at it from the side, that angle would be acute right there. So if you have a pyramid that you can use, you can see that it's not a right angle there. The real height would come down near the center and make a right angle with the floor or base, so to speak. Now, in order to find that, since I don't know the height, I'm going to do a little Pythagorean theorem. The hypotenuse over there is 17. We don't know the height. We got a right angle right here, and at the bottom here, that would be 8. Where did I get 8 at? If the whole side is 16, that would have to be 8. So I guess that does make that the center. A squared plus B squared equals C squared. Very important to make sure you understand the Pythagorean theorem or Pythagorean triples. 17 squared is 289. I had to ask Siri. Subtract your 64. I'm trying to get x by itself. 225 is equal to x squared, and you get rid of a square by square rooting. X is 15. Now we did all that to find out that that height is 15, which makes the rest of our problem real easy because we already had everything else we needed in the calculation. We just fill in the height of 15 there. So if we would use 17, it would not be correct. Triangular pyramid. We got a triangle base. So when I substitute my capital B in, I'm going to use the triangle formula. Triangle formula, 1/2 BH. So I still got the 1/3 in the front, and I still got the height of the pyramid in the back. Focus on just the triangle, which is the base. It's this part. I need a base and a height that form a right angle. That would be the 3 and the 11 that are forming the right angle in the triangle. Guess you could go ahead and multiply that and call that 1/6 if you wanted to. What's the height of the pyramid? 8 is a good height. It comes down to the base. It makes the right angle. So these are the pieces that I need. Cubic meters once you do your calculation, whatever 1/6 times 3 times 11 times 8 is. Nothing tricky about this cone. We got a diameter, it appears. 20 represents this whole part because the way it's centered or written. 27 is the height right there. 1/3, the base is a circle, and the height, my radius, again, is 10, not 20. That 20 splits to 10 and 10. 27 is the height. It makes a good right angle with the base. If 27 would have been here, that's not the height. I would have had to do Pythagorean theorem again if that was the case. Cubic inches on the units after that. To wrap things up in my flip book, and doing spheres. Spheres is actually a really simple shape to do because there's no bases. It's 4/3 pi r to the third. Remember, volume loves the number 3. All too many times I myself will do pi r squared. We're just so used to doing pi r squared. If you have a half a sphere, or aka a hemisphere, you just take your formula and divide it by 2. So you're literally just taking your radius of 8 and plugging it in. Be careful, you might be given the diameter is 9, so the radius would be 4.5. Plug it in, 4/3 pi, 4.5 to the third. Cubic feet, still. .7. Looks like 27. 2.7 is the radius here. 4/3 pi, 2.7 to the third. But be careful, hemisphere over here, 4/3 pi, 13 to the third. First time I did this, forgot the times or divide by 2. I'm sorry. It's a half of a sphere. Nothing tricky about 23 and 24. So again, this video is supposed to be kind of like a review for high school level kids, going back and touching on some volume from probably middle school. My next video, one of the main focuses in this unit is advanced level type volume questions, solving problems with volume. Like we'll work backwards and find a radius or examine some of the effects that happen when you square a radius or triple a radius in different shapes. Thank you for watching.